Hello, in this lecture we find out the length of line segment X. In the drawing we have a quarter circle, A or B is a quarter circle. Inside this quarter circle we have this semicircle, OB is a semicircle. And we also know that side AO equals to 10 units in its length. Our mission is to find out the length of this line segment AM that is equal to X according to what is given us in the question. So first of all, because of the fact that AOB is a quarter circle, it means that this angle AOB equals to 90 degrees in its size. And also side AO and side OB are equal to each other. They are both the radii of this quarter circle, therefore they are equal to each other. But AO equals to 10 units, therefore OB must be also equal to 10 units in its length. So the radius of this quarter circle equals to 10 units. But OB is not only the radius of this quarter circle, but it is also the diameter of this semicircle. So the diameter of this semicircle equals to 10 units, therefore the radius of the semicircle must be equal to 10 over 2, that is 5. The radius of this semicircle equals to 5 units. We define the center of this semicircle as P. We define the point of tendency of tangent AM with this semicircle as Q. And we join points P and Q together by a straight line. Point P is the center of the circle, point Q is the point on the circle itself. Therefore PQ is the radius of this semicircle, that is equal to 5 units. Again, OP is the radius of this semicircle, that is 5. PB is also the radius of this semicircle, that is equal to 5 units in its length. And we have here rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. Here we have tangent AB, that is tangent to this circle at point M. Point M is the point of tendency. And we have the radius OM that is drawn to the point of tendency. That is to say, it is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever we have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees and this angle equals to 90 degrees according to this rule number 1. We can actually implement rule number 1 in our drawing. Because in our drawing we have the radius PQ of the semicircle that is drawn to point Q, that is the point of tendency of tangent AM with this semicircle. And whenever you have a radius that is drawn to the point of tendency, then tangent AM will be perpendicular to the radius QP. If AM is perpendicular to QP, it means that this angle equals to 90 degrees. And this angle also equals to 90 degrees according to rule number 1. We have also here rule number 2. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. We have the common external point P. From the common external point P, we have two tangents to this circle, tangent PA and tangent PB. And according to rule number 2, they are equal to each other. That is to say, PA equals to PB. We can implement rule number 2 in our drawing. Because in our drawing, if you focus on the common external point A, from the common external point A, we have two tangents to this semicircle, tangent AO and tangent AQ. And according to rule number 2, they are equal to each other. That is to say, AO equals to AQ, but AO is 10, therefore AQ must be also equal to 10 units in its length. In the next step, we'll extend side AM and side BO by a straight line until they touch each other. And we define the touching point of the extended side AM and side OB as point N. By doing this construction, we actually created here the right big triangle, triangle AON. We define this angle as theta, so angle ONA equals to theta according to our definition. We focus on the right triangle AON. In the right triangle AON, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees, that is the sum of the angles in any triangle. Likewise, we focus on the right green small triangle, triangle QPN. This right triangle, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Okay. In the next step, we'll prove that the right great triangle, triangle AON, is similar to the right small triangle, triangle QPN. So I write it down. The right great triangle, triangle AON is similar to the right green triangle, triangle QPN. So right triangle AON is similar to the right green triangle, triangle QPN. First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. So this is the angle AON in the right triangle AON. And it is equal to this angle in the green triangle, triangle QPN. This is actually angle PQN. Repeat again. Angle AON in the big triangle AON equals to angle PQN in the green triangle. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this angle theta, it is a common angle that belongs to both triangles, so we can write down that angle theta equals to itself as a common angle that belongs to both triangles. So if we write to angle theta as it belongs to the big triangle, triangle AON, it will be called angle ONA. And it is equal to itself. If we write to angle theta as it belongs to the small green triangle, triangle PQN, it will be called angle PNQ. Repeat again. This equation means that angle theta is equal to itself. We just call to angle theta two different names. Angle theta is a common angle that belongs to both triangles. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is angle OAN. And it is equal to this angle, that's actually angle QPN. Repeat again. Angle OAN equals to angle QPN. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually prove that all the three angles in the right triangle AON, in the right big triangle AON, are correspondingly equal to all the three angles in the right small green triangle QPN. Therefore, we actually proved that the right big triangle AON is similar to the right green small triangle QPN according to angle similarity rule. So I write it down. The right big triangle AON is similar. This is the sign of similar to the right green triangle QPN according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that AO, side AO in the big right triangle AON over side QP in the small green triangle QPN equals to side AN in the big right triangle AON over side PN in the small green triangle PQN. Repeat again. We derive that AO over QP equals to AN over PN, and it is also equals to side ON in the big right triangle AON over side QN in the small green triangle QPN. Repeat again. We derive that AO over QP equals to AN over PN equals to ON over QN. AO is 10. Over QP is 5. And it is equals to AN. What is the length of AN? From the drawing it is very easy to see that AN in total equals to AQ plus QN. That is to say AN equals to AQ, that is 10 plus QN. So in total AN equals to 10 plus QN. Over PN. PN in total equals to PB plus BN. That is to say PN equals to PB, that is 5 plus BN. So in total PN equals to 5 plus BN. And it is equals to ON. ON in total equals to OP plus BB plus BN. So ON equals to OP, that is 5 plus PB, that is 5 plus BN. So in total ON equals to 5 plus 5 plus BN. That is to say ON equals to 10 plus BN. Over QN. QN is the missing side, so we leave it as it is. In conclusion, found out that 10 over 5 equals to 10 plus QN over 5 plus BN, and it is equals to 10 plus BN over QN. 10 over 5 is 2. So 2 equals to 10 plus Qn over 5 plus Bn, and it is equals to 10 plus Bn over Qn. So here those two sides are equal to each other, so we create equation number 1 from those two sides that are equal to each other. So according to equation number 1, 2 equals to 10 plus Qn over 5 plus Bn. Those two sides are also equal to each other, so we get the equation number 2 from those two sides that are equal to each other. According to equation number 2, we get that 2 equals to 10 plus Bn over Qn. So we have here two equations. Here we multiply this equation, equation number 1, by 5 plus Bn. And we get that according to equation number 1, two times 5 plus Bn equals to 10 plus Qn. Repeat again, we actually found out that according to equation number 1, according to equation number 1, 2 times 5 plus Bn equals to 10 plus Qn. Here we'll open the brackets on this side of this equation, equation number 1, and we get that according to equation number 1, 2 times 5 is 10, plus 2 times Bn is 2Bn, is equal to 10 plus Qn. So here we have 10 on both sides of the equation, so 10 will get cancelled, and we're left only with Qn that is equals to 2 times Bn. Again, according to equation number 1, we found out that Qn equals to 2 times Bn. While according to equation number 2, we have already found out that 2 equals to 10 plus Bn over Qn. Here we multiply this equation, equation number 2 by Qn, and we get that according to equation number 2, two times Qn equals to 10 plus Bn. So according to equation number 2, 2 times Qn equals to 10 plus Bn. But we have already found out that according to equation number 1, Qn equals to 2 times Bn. So we can substitute Qn in this equation, equation number 2, by 2 times Bn. We do it now, and we get that according to equation number 2, 2 times Qn, and Qn equals to 2Bn. That is equals to 10 plus Bn. Here, 2 times 2Bn is 4Bn. So 4Bn equals to 10 plus Bn according to equation number 1. Here we subtract Bn from this equation, equation number 1. We get that according to equation number 1. 4Bn plus Bn is 3Bn. that is equals to 10. According to equation number 1, 3 bn equals to 10. Here we divide this equation number 1 by 3, and we get that according to this equation number 1, Bn equals to 10 over 3 units in its length. So you can write down in the original drawing that the graph of line segment Bn is 10 over 3 units. According to equation number 1, Qn equals to 2 times Bn, and we just right now found out that according to equation number 2, Bn equals to 10 over 3. Therefore, Qn actually equals to 2 times Bn, and Bn is 10 over 3, so it is 2 times 10 over 3. 10 times 2 is 20, so this expression equals to, in total, to 20 over 3. We actually found out that according to equation number 1, Qn equals to 20 over 3 units in its length. Here, this line segment Qn equals to 20 over 3 units in its length. In the next step, we'll complete this quarter circle to a circle. So completed this quarter circle to a circle, and we'll extend side BO by a straight line until it touches the circle. And we'll define the touching point of the extended side BO with this circle as C. Point O is the center of the circle. Point C is the point of the circle itself, therefore OC is the radius of this circle. Because of the fact that we completed the quarter circle to a circle, it's very clear that the radius of the quarter circle is the same as the radius of the quarter circle. The radius of the quarter circle is the same as the radius of the circle, and the radius of the quarter circle AO equals to 10, therefore the radius of the circle CO must be also equal to 10 units in its length. In the next step, I present to you a new rule, and we will implement the new rule in our drawing. According to the new rule, that's actually rule number 14. Rule number 14 is true in any circle. So in any circle, if you draw two chords A, B, and C, D in the circle, from the common external point P, then the following equation will be true, that PA times PB equals to PC times PD. So here in the drawing we have a circle and we have the common extent point P. From the common extent point P, we do two chords inside this circle. Here, this is called AB, this is called CD. So in this drawing, the following equation is true, that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. Okay, you can actually implement rule number 14 in our drawing. Why? Because in our drawing we have the common extent point N. From the common extent point N, we have two chords inside this circle, called MA and called BC. So all the requirements of rule number 14 are met, therefore we can implement here rule number 14. According to rule number 14, NB times NC equals to NM times NA. Again, NB times NC equals to NM times NA. So I write it down. If we focus on the common extent point N, we have chord MA and chord BC. Therefore, according to rule number 14, NB times NC equals to NM times NA. Repeat again. If you focus on the common extent point A, according to rule number 14, you get that NB times NC equals to NM times NA. Again, here we have to find out the length of this line segment MN. From the drawing, it is very easy to see that MN equals to QN minus QM. Repeat again. From the drawing, it is very easy to see that Mn equals to Qn minus Qm. Qn is 20 over 3. Minus Qm. So in total, we actually found out that Mn equals to 20 over 3 minus Qm. Okay, so I can write down in the original drawing that this line segment Mn equals in total to 20 over 3 minus Qm. Now we return to rule number 14. According to rule number 14, NB times NC equals to NM times NA. NB equals to 10 over 3 units. Times NC. What is the length of line segment NC or CN? CN equals in total to CO plus OP plus PB plus BN. So CN equals to CO, that is 10, plus OP, that is 5, plus PB, that is 5. So in total 10 plus 5 is 20, plus BN, that is 10 over 3. So in total CN equals to 20 plus 10 over 3. Cn or Nc equals in total to 20 plus 10 over 3 units in itself, and it is equals to Nm. Nm or Mn, it is the same. Nm equals to, just write down for now that Nm equals to 20 over 3 minus Qm. So it is Nm times Na. What is the length of Na? From the law in itself, it is very easy to say that Na or An in total equals to Aq plus Qn. That is to say An equals to Aq, that is 10, plus Qn, that is 20 over 3. So in total, An equals to 10 plus 20 over 3. So we should have found out here that 10 over 3 times 20 plus 10 over 3. Here we multiply 20 by 3 and then we divide it by 3 in order to have a common factor with 10 over 3. And we get that in the numerator we'll have 20 times 3 is 60 and 60 plus 10 is 70. So in total in the numerator we have 70 divided by 3. That is equals to 20 over 3 minus Qm. So here we'll multiply minus Qm by 3 and then we'll divide it by 3 in order to have a common factor with 20 over 3. So in the numerator in total we will have 20 and minus Qm times 3 is minus 3 Qm. So in total in the numerator we have 20 minus 3 Qm divided by 3 times 10 plus 20 over 3. Here we multiply 10 by 3 and then we'll divide it by 3 in order to have a common factor with 20 over 3. 10 times 3 is 30 and 30 plus 20 is 50. So in total in the numerator we have 50 divided by 3. So in this equation, in both sides of the equation, in the denominator we have 3 times 3, that is 9. Therefore we'll multiply this equation by 9 in order to cancel the denominator, that is 9. So after we multiply it by 9, in this side of the equation we left only with 10 times 70. That is equals to, on the other side of the equation we left only with 20 minus 3 Qm times 50. Repeat again. After we cancel 9 on both sides of the denominator, we actually left only with 10 times 70, that is equals to 20 minus 3 Qm times 50. Here we divide this equation by 10 and we'll get that according to this equation 10 over 10 is 1, so in this side of the equation we left only with 70. That is equals to, on the other side of the equation we have 20 minus 3 Qm times 50, and 50 over 10 is 5. So in conclusion we found out that 70 equals to 20 minus 3 Qm times 5. Here we'll open this side of the equation. We'll open the brackets on this side of the equation. We get that 70 equals to 20 times 5 is 100. Minus 3 Qm times 5 is minus 15 Qm. So in conclusion, found out that 70 equals to 100 minus 15 Qm. Here we subtract 70 from this equation and get that according to this equation 70 minus 70 is 0. And it is equals to 100 minus 70, this is 30 minus 15 Qm. Here we'll add 15 Qm to this equation and we get that according to this equation 15 Qm equals to 30. Here we divide this equation by 15 and finally we'll get that Qm equals to 30 over 15, that is 2. So QM equals to 2 units in its length. We can write down in the original drawing that this line segment QM equals to 2 units in its length. Our mission is to find out the length of line segment AM that's equal to x. Repeat again, we have to find out the length of AM that's equal to x according to what is given as the question. From the drawing itself, it is very easy to see that this line segment AM in total equals to AQ plus QM. Again, AM equals to AQ plus QM. So write it down. AM equals to AQ plus QM. That is to say, AM equals to AQ, that is 10, plus QM, that is 2. So in total, AM equals to 10 plus 2, that is 12. In conclusion, found out that x that is equal to AM equals to 12 units in its length. And that is the answer to our question. I'll repeat again. The length of this line segment AM that is equal to x, it is equal to 12 units. Okay, so in the next step, I will summarize the lecture. In this lecture, we found out the length of this line segment AM because that is equal to x according to what is given as the question. So in the drawing, we have a quarter circle. AOB is a quarter circle. Inside this quarter circle, we have this semicircle. OB is a semicircle. And we also know that side AO equals to 10 units in its length. Again, our mission is to find out the length of this line segment AM that is equal to x. So first of all, we know that AOB is a quarter circle, therefore this angle equals to 90 degrees, and side AO must be equal to side OB. Both sides are the radii of this quarter circle, therefore they are equal to each other. But AO equals to 10, therefore OB must be also equal to 10 units in its length. Here OB equals to 10 units. And so OB that is equals to 10, it is not only the radius of this quarter circle, but it is also the diameter of this semicircle. So we know that the diameter OB of this semicircle equals to 10 units, and therefore the radius of this semicircle must be equal to 10 over 2, that is 5. We define the center of this semicircle here as P. So OP, that is the radius of this semicircle, equals to 5 units. PB also equal, it is the radius of the semicircle that is equal to 5 units. We define the point of tendency of tangent AM with this semicircle as Q. Then we join points P and Q together by straight line. Point P is the center of the semicircle, point Q is the point of the semicircle itself, therefore PQ is the radius of this semicircle that is equal to 5 units. Then we extended side AM and side OB by a straight line until they touch each other. Here we define the touching point as point N. By doing this construction, we created here the right triangle AON. In this right triangle AON, we define this angle as theta. This angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, in the green triangle, again right triangle PQN, this angle equals to theta, this angle equals to 90 degrees, and the missing angle must be equal to 90 degrees minus theta, according to the same logic. Then we proved that the right big triangle AON is similar to the small right green triangle QPN. Why? Those two right triangles are similar to each other. First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, that is a common angle, it belongs to both triangles, so we can write down that angle theta equals to itself. And finally, those two angles are both equal to 90 degrees cos theta, therefore they are equal to each other. So we actually prove that all the three angles of the right big triangle AON are correspondingly equal to all the three angles of the green small triangle, the green small right triangle QPN. And therefore, those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that AO in the big triangle over QP in the small triangle equals to AN in the big triangle over PN in the small triangle, and it equals to ON in the big triangle over QN in the small triangle. AO is 10, QP is 5, AN, what is the length of AN? From the drawing it is very easy to see that AN in total equals to AQ plus QN. That is to say AN equals to AQ, that is 10 plus QN. So in total AN equals to 10 plus QN. Yeah. AN equals to 10 plus QN over PN. What is the length of PN? Yeah. PN equals to PB plus BN. That is to say PN equals to PB, that is 5 plus BN. So in total PN equals to 5 plus BN. Yeah. PN equals to 5 plus BN. And it is also equals to ON. What is the length of line segment ON? ON in total equals to OP plus BB. Again, ON in total equals to OP plus PB plus BN. So ON equals to OP, that is 5, plus PB, that is 5. 5 plus 5 is 10, plus BN, that is 10 over 3. So in total, ON equals to 10 plus BN. Okay. So ON equals to 10 plus BN over QN. QN is the missing side, so we leave it as it is. 10 over 5 is 2, so in conclusion we found out that 2 equals to 10 plus QN over 5 plus BN, and it is equals to 10 plus BN over QN. Those two sides are equal to each other, therefore we created the equation number 2 from those two sides are equal to each other. So according to equation number 1, here we created the equation number 1 from those two sides that are equal to each other. According to equation number 1, 2 equals to 10 plus QN over 5 plus BN. Those two sides are also equal to each other, therefore we created the equation number 2 from those two sides that are equal to each other. According to equation number 2, 2 equals to 10 plus Bn over Qn. So we have here two equations. Here we multiply this equation number 1 by 5 plus Bn, and we found out that according to equation number 1, two times 5 plus Bn equals to 10 plus Qn. Here we open the brackets on this side of this equation number 1. We found out that 2 times 5 is 10, plus 2 times Bn is 2Bn, that equals to 10 plus Qn. Here we have 10 both sides of the equation, so 10 will get cancelled, and we left only with Qn, that is equals to 2Bn. According to equation number 1. Well, according to equation number 2, we already found out that 2 equals to 10 plus Bn over Qn. Here we multiply this equation number 2 by Qn. We found out that 2 times Qn equals to 10 plus Bn. So according to equation number 2, 2 times Qn equals to 10 plus Bn. But according to equation number 1, Qn equals to 2 times Bn. So we can substitute Qn in this equation number 2 by 2 times Bn from equation number 1. We did it and we found out that 2 times Qn, and Qn is 2Bn, 2 times Bn, that is equal to 10 plus Bn. 2 times 2Bn is 4Bn, so 4Bn equals to 10 plus Bn. Here we subtracted Bn from this equation number 1, and found out that 4Bn minus Bn is 3Bn, so 3Bn equals to 10. We divided this equation number 2 by 3, and found out finally that Bn equals to 10 over 3 units in its length. Here this line segment Bn equals to 10 over 3 units in its length. According to equation number 1, we have already found out that Qn equals to 2 times Bn. So Qn equals to 2 times Bn, and Bn is 10 over 3. So it was 2 times 10 over 3. 2 times 10 over 3 is 20 over 3. If we can find out that Qn equals to 20 over 3 units in its length. This line segment Qn equals to 20 over 3 units in its length. Then we completed this quarter circle to a circle, and we extended side BO until it touches the circle at point C. Here point O is the center of the circle, point C is the point of the circle itself, therefore OC is the radius of this circle. The radius of the circle and the radius of the quarter circle are the same because we completed the quarter circle to a circle. And the radius of the quarter circle is 10, therefore the radius of the circle must be also equal to 10. That is to say, OC equals to 10. Then I presented to you rule number 14, and we implemented rule number 14 in our drawing. According to rule number 14 is true in any circle. So in any circle, if we draw two chords A, B, and C, D in the circle, from the common extreme point P, then the following equation will be true, that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. So we have here a circle, and we have the common extreme point P. From the common extreme point P, we draw two chords inside this circle, chord AB and chord CD. So in this drawing, the following equation will be true, that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. We can actually implement rule number 14 in our drawing. Why? Because in our drawing, we also have the common extreme point N, and from the common extreme point N, we have two chords inside this circle, chord AM and chord BC. Therefore, all the requirements of rule number 14 are met, and for that reason, you can implement here rule number 14. According to rule number 14, NB times NC equals to NM times NA. Again, NB times NC equals to NM times NA. I repeat again. According to rule number 14, if we focus on the common extreme point N, NB times NC equals to NM times NA. We calculated the length of line segment NM. This is line segment NM or MN. MN, from the drawing it is very easy to see that MN in total equals to QN minus QM. Again, MN equals to QN minus QM. Repeat again. MN equals to QN minus QM. QN is 20 over 3 minus QM. So in total, MN equals to 20 over 3 minus QM. So we write down here in the original drawing that MN in total equals to 20 over 3 minus QM. Then we return to rule number 14. Again, according to rule number 14, if we focus on the common extreme point N, NB times NC equals to NM times NA. NB is 10 over 3. Yeah, NB is 10 over 3 times NC. What is the length of NC? In total, NC or CN, it is the same. CN equals to CO plus OP plus OB plus BN. So CN in total equals to CO, that is 10, plus OP, that is 5, plus PB, that is 5. 10 plus 5 is 20, plus Bn, that is 10 over 3. So in total, Cn equals to 20 plus 10 over 3. Repeat again. Cn in total, Cn or Nc equals to 20 plus 10 over 3. And it is equal to Nm. We just write down found out that Mn or Nm equals to 20 over 3 minus Qm times Na. What is the length of Na? Na in total, or Na or An, it is the same. An equals to Aq plus Qn. That is to say, An equals to Aq, that is 10, plus Qn, that is 20 over 3. So in total, An equals to 10, An equals to 10 plus 20 over 3. Repeat again. An equals to 10 plus 20 over 3. So here we have 10 over 3 times 20 plus 10 over 3. We multiplied 20 by 3 and then we divided by 3 in order to overcome the factor with 10 over 3. So 20 times 3 is 60 and 60 plus 10 is 70. So in total, in the numerator of this expression, we have 70 divided by 3 and it is equals to 20 over 3 minus Qm. Here we multiplied minus Qm by 3 and then we divided by 3 in order to overcome the factor with 20 over 3. So in the numerator, in total, we will have 20 minus Qm times 3 is minus Qm. So in total, in the numerator, we have 20 minus 3 Qm divided by 3 times 10 plus 30, 10 plus 20 over 3. Here we multiplied 10 by 3 and then we divided by 3 in order to overcome factor with 20 over 3. 10 times 3 is 30 and 30 plus 20 is 50. So in total, in the numerator of this expression, we have 50 divided by 3. So here on both sides of the equation, we have 3 times 3 in the denominator. 3 times 3 is 9. Therefore, we multiplied this equation by 9 in order to eliminate the denominator 9. After we eliminated the denominator 9 in this equation, we left only with 10 times 70, that's equals to 20 minus 3 Qm times 50. Here we divided this equation by 10. 10 over 10 is 1, so here we left only with 70. That equals to 20 minus 3 Qm times 50. 50 over 10 is 5. So in total, we found out actually that 70 equals to 20 minus 3 Qm times 5. Here we open the brackets on this side of the equation. We found out actually that 70 equals to 20 times 5 is 100. And minus 3 Qm times 5 is minus 15 Qm. So in conclusion, we found out that 70 equals to 100 minus 15 Qm. Here we subtracted 70 from this equation and found out that 70 minus 70 is 0 and 100 minus 70 is 30 minus 15 Qm. So in conclusion, we found out that 0 equals to 15 minus Qm. We added to this equation 15 Qm and finally we found out that 15 Qm equals to 30. Here we divided this equation by 15. We found out that Qm equals to 30 over 2, that is 5. So Qm equals to 2 units in its length. This line segment Qm equals to 2 units in its length. Our mission is to find out the length of this line segment AM, that is equal to x. Again, we have to find out the length of line segment AM, that is equal to x. From the drawings, it's very easy to see that AM in total equals to AQ plus QM. Again, AM equals to AQ plus QM. So here you can write down that AM equals to AQ plus QM. AQ is 10 and QM is 2. So in total AM equals to 10 plus 2, that is 12. So actually found out that X, that is equal to AM according to what is given in the question, it is equal to 12 units in its length. Repeat again. This line segment AM, that is equal to X, it is equal to 12 units in its length. Okay, thank you very much.